Okay. Good afternoon, everyone. I think we'll make a start. There's probably still people joining us, but we've got a lot of stuff to go through. So let's make a start. So this is the last day of the conference, and I hope you've been enjoying things happening. This is the last afternoon, and we'll be presenting the tutorial on what and how of machine learning transparency, building bespoke explainability tools with interoperable algorithmic components. So building tools is an important part of this. So this is a hands-on tutorial. And so we will a large part of the tutorial in the second half will be devoted to actually doing this in practice, and for that we will move to Slack, because we will allow people to try out the tools that we make available and to ask us questions, and we can help you with that. So I'll say a bit more about that in a moment. So it's a hands-on tutorial. It lasts 4 hours. It's 2 p.m. on the continent, 1 p.m. in Bristol. So we'll be finished by 6 continental time. There's a couple of links here. So the tutorial webpage is events.fatforensics.org. So fatforensics is the toolbox that we will be using. We will also use Slack, so the Slack workspace is linked there, and there's a registration link which is on the tutorial homepage, and it will also be posted here. I think Kacper, if you could post the registration link here in the chat. So there's a couple of entry points here to this presentation. So one of them is via the Whova app or the Whova mobile app. Another one is directly via Zoom. So that means that there's also different ways in which people can ask questions. If you can, we would prefer you to ask questions through the Q&A on Zoom, but we'll also keep an eye on the Q&A in Whova. There is also a difference between posting a question in the Whova slot for the whole tutorial versus posting it on the particular section of the tutorial that is live at the moment. I think the advice there would be to post it on the tutorial section, but we'll have to work with that as it happens, and I'm sure there will be some things that we will miss here. On Whova, there's also the possibility of raising your hand. So I think between these possibilities, we'll work it out somehow. We will record this, and the recordings will be published after the event via the tutorial homepage. So who are we? So there are 4 instructors this afternoon. And you see something about them on this slide. So the important people are on the left and the less important people are on the right. Sorry, Raul. So to start with myself, I'm a professor at Bristol. I'm working on a range of topics, a lot of which have to do with human-centered and interactive AI. But I also work on more technical machine learning topics. On Monday, we gave a tutorial on calibration of machine learning models. Raul is a colleague of mine in Bristol. We're all from Bristol, so Raul and I collaborate on applications of data science in healthcare, for example. Kacper and Alex are PhD students and researchers. So Kacper has been the lead developer of Fat Forensic. So Fat Forensic has been a short project that was funded in part by Thales UK, and that has led to the development of the Fat Forensics toolbox. So Kacper was the lead developer, and Alex was one of the core developers. So you'll hear more from all of these people during the tutorial. So the overall schedule, we have part 1 is the models of black box explainers. So I will introduce that very briefly and then hand over to Kacper, who will talk about the what, why, and how of algorithmic transparency, and also talk more about this particular topic of surrogate explainers. Part 2 is getting to know Fat Forensics. So this will hand over to Alex for 2 video presentations, and then we will have a break. And part 3 is mostly the hands-on ones. So again, Alex will come back after the break to give an introduction to the hands-on resources. After which, so it will be 4:30 continental time by then, we will move over to Slack. And this is like, you know, when we designed this tutorial, of course, this was pre-COVID. We were anticipating that we would all be in the same room. So imagine that this session is about, if you imagine yourself to be in that room, you've got your own laptop, you've got the software installed, and people like Kacper and Alex and other people are walking around and to sort of give advice and answer questions and so on. So instead of that physical room, we have Slack now. So still, you know, if you're interested in the hands-on part, then you will be encouraged to run the software and the tools and to work through the notebooks, and we will be able to answer questions via Slack. And then finally, for the last 10 minutes, Raul will sort of bring us all back together and do a quick summary and a recap, and maybe a bit of outlook of where we're going with this. So that's the overview of the tutorial. A little bit of background about ourselves. So where are we coming from? So in Bristol, we have quite a big AI group we call the Intelligent Systems Lab, where we do a lot of machine learning and data science, but not only the data-driven stuff. We are also interested in reasoning, uncertainty handling, measuring things, so more knowledge-intensive stuff. And then finally, we're interested in doing all these things in a way that makes sense to humans, which is where, for example, explainability fits in. So some examples, there's a wide range of things that we do which fit under one, maybe 2. So I already mentioned classifier calibration. It says recording available soon, but that's actually already there. I have quite a theoretical project on measurement theory, because it turns out that actually in machine learning, there's a lot that we can improve on how we measure things like the performance of machine learning algorithm. And there's a link there to a talk I gave at XAI 2019 about what's good and bad about performance evaluation in machine learning. So that's a little bit about us. When we say interactive and human-centered AI, what do we mean? Well, it's really important. So we think of most AI applications as collaborative AI. It's not so much autonomous AI. It's not so much about autonomous cars, but it's about the car that does part of the driving, but also needs to involve the human, and the human needs to explain, needs to understand what's happening. So whenever there's a data processing pipeline, there's going to be a human agent somewhere. It may be an end user, it may be an operator, it may be somebody who needs to certify whether the AI still works correctly. So trustworthiness obviously is an important part of this. So we as humans want to trust our AI. To make that a little bit more specific, people often talk about fairness, accountability, and transparency, which is where the FAT in FAT forensics comes from. And we are also particularly interested in Bristol to study this from the perspective of other human-centered disciplines. So our view is that AI is not just an engineering discipline. We have a lot to learn from cognitive scientists, psychologists, social scientists, and so on. And we have a center for doctoral training. So we have a PhD program, which is actually about a lot of these things about interactive AI. I mentioned trustworthy AI. That's another way of sort of another buzzword, if you want, but it's something that is important, and it's something I think where Europe is leading the way. So we just started our participation in a big 12 million euro funded network called Taylor, which stands for Trustworthy AI through Integrating Learning, Optimization, and Reasoning. So this network is really about combining different AI paradigms. So it's not just about learning, it's not just about reasoning, it's not just about optimization, it's about combining these things. So there are a number of AI networks that have just been funded by Horizon 2020. And again, there will be a lot of activity by these networks, such as summer school educational events, training materials, other resources, PhD curriculum. So this is another interesting space to watch. Okay, so let's become a little bit more specific about FAT forensics. The URL is there. It's a modular Python toolkit for algorithmic fairness, accountability, and transparency. It has kind of two typical use cases. So one is for end user, but it's also a research toolkit for people wanting to try out and play with different FAT components. So in order to do that, it's really important that we have this kind of common structure that we don't, so currently a lot of the techniques implemented in the literature are sort of implemented as standalone. So what we did in FAT forensics is combining a lot of published approaches in the literature, deconstructing them, taking them apart, and then re-implementing those basic building blocks and putting it all together. And sometimes in the process, actually improving or extending the published method. So this is going to be our main framework for today. So what about explainability and black box explainability? So typically, if we have a black box model, let's say the standard example is a deep neural network, but there are many other models that are in themselves not particularly transparent. They take in data, they make predictions, the predictions are presented to the human, and often we want to explain those predictions. So many of you will have heard about models like SHAP and LIME, which are kind of separate explainers that use surrogate models. So if you have a query point, then you want to explain prediction on the query point. These explainers train a surrogate model, sort of a little bit of a model that simulates part of the black box model and uses that surrogate model to explain to the user what's going on. But these explainers themselves can be black boxes. So it's also important to build the explainers themselves in a transparent way. So for example, if you've if you've seen Lime in action, then there are kind of image segmentation algorithms within Lime, if you apply it to images, that are really important parts of the whole explanatory mechanism. And it's important to understand how those segmentation building blocks work. So the explainer shouldn't be a black box itself, but should be more modular. Okay, and secondly, a second consideration is that it's a bit naive to think that we can just build one ideal explainer and be done with it. So our starting point is that there is no universal explainer. Something that works in one use case may not work in another use case. Explanation is an act of communication, it's interaction, it's an act of dialogue. So often we want to allow the end user to ask questions again, sort of, okay, why did you deny my loan? And then you could, the system could say, well, you know, you didn't earn enough. And then the end user could say, well, would it have made a difference? I'm about to get a pay rise of £10,000. Would that make a difference? And then the explanation algorithm could then answer that question. So that's quite a big picture, of course, but the point is that explainability is not the one thing. And it depends on the whole situation, on the domain, on the use cases. And so we will often find ourselves in a situation where we have to build an explainer for a particular application, for a particular use case, for a particular domain. And so that's why it is important to have these modules that allow us to cover more of this space than a single implementation would allow. So that's kind of the game we're playing here. So we want to look inside that explainer box and build it from different modules, and then also want to understand what is the effect of taking one module out and replacing it by another module. Right, so this is really about the science of explainability or the practice of explainability. What happens if I replace this box with this box? That's really what this afternoon is about, I think. And so I explained a little bit the idea of a surrogate. So that's kind of the explainer has a little surrogate model that covers part of the black box model in a relevant area. Surrogates have been studied for images. I talked about these segmentation, superpixels and things like that, but you can also have surrogates for text data, which are parts of sentences, and you can have surrogates for tabular data. And it turns out that although you know, techniques like Lime in principle work for these different kinds of data, the way how it works out in practice is quite it's quite specific. So we do need to look at different kinds of data. So explainability, surrogate models for images are a little bit different from surrogate models for tabular data. So the hands-on part, we will talk about all these data types, but the hands-on part will focus on tabular data. And there are the building blocks are, how do you sample your data around your query point? What kind of interpretable representations do you have? So for instance, the superpixels, an image as a set of segments or superpixels, that's one form of interpretable representation. What other ones are there? What would an interpretable representation look like for text or for tabular data? And the third component is then how do you generate an explanation, and what are the possible choices that you can make there? So a little bit about the learning outcomes. So it's about not just understanding explanations that are generated by explainers, but understanding the explainers themselves, getting an appreciation of surrogates and local surrogates and going a little bit in depth there, and gaining hands-on experience by essentially building your own surrogate explainer and how to evaluate them and how to assess the effect of the choices that you are making there. Okay, so I think that's me done. So I'm going over to Kacper now. So Kacper, I'm going to stop sharing my screen and mute and stop my video, and then it's over to you.